ladies and gentlemen, so today we are going to dive into chapter 3, and so that means it's time to glue in a new table of contents. If you are in class, you will receive this pink table of contents page when you're in class next, so leave a blank page if you're filling this out at home. If you're a digital learning student, go into the files section on Teams and you can download and print the PDF so you can keep track of all of our lessons here. So let's start talking about 3.1 and 3.2, where we are going to graph and solve linear equations. First, we have skills that we're going to work on. We are going to interpret key features of graphs and tables of functions in terms of the quantities and sketch graphs showing key features. We will graph linear and quadratic functions and show intercepts, maxima, and minima. And we will understand that a graph of an equation in two variables is the set of all points plotted in the coordinate plane forming a curve, which could be a line. This is a big one. This REI 10 we've been working on all throughout this year so far, and we're going to continue working on it. So now let's talk some vocabulary. Our first term is the term linear equation, and last year in math you spent a lot of time learning about linear equations. A linear equation is an equation whose graph is a straight line. And there are three different forms that we can have our linear equations. What we're going to deal with first this year is standard form, where we have ax plus by equals c. Slope-intercept form is the type that you used most commonly last year, where we have y equals mx plus b. We can also have point-slope form, which we'll talk more about later this year. Y minus y1 equals m times the quantity x minus x1. Today we're also going to throw in some new terms, but we've got two review terms to talk about. A constant is a term that does not contain a variable. We talked about that in lesson 1.4. And these parts here, that a in front of the ax and the b in front of by and the c, those are my constants. Intercepts are points at which a line or a curve cross an axis. Well, with intercept, we're going to take that one step farther today, and we're going to talk about the zeros of a function. The zeros of a function are values of x for which the function of x is 0. So my x-intercept. We can also have families of graphs. Families of graphs are graphs and equations of graphs that have at least one characteristic in common. The simplest graph in a family is the parent function. We can also have roots. A root is any value that makes an equation true. We're talking about solutions when we're talking about roots. So let's dive into finding intercepts. First, to find my x-intercept, there are three different ways I can approach it. First, if I have an equation, I want to let y equal 0. So if I look at my sample here, I have an equation in standard form, 3x plus 5y equals 15, and I want to let y equal 0. So I'm going to plug in a value of 0 for y, and I get 3x plus 5 times 0 equals 15. Well, using my order of operations and my steps for solving equations, I get 3x equals 15, which tells me that when y is 0, x is 5. So my x-intercept is 5. But if I'm given a graph, I just need to look at the graph and find where the line crosses the x-axis. If I have a table, to find my x-intercept, I find the x value that's paired with a y value of 0. So now we're going to do the same sort of thing for our y-intercepts. If I have an equation, this time I'm going to let x equal 0. And my sample equation on this one is y equals negative 3/5 x plus 5. This one here is in that slope-intercept form that we talked about last year. I'm going to plug in x equals 0, and I find out that when x is 0, y is 5. So my y-intercept is 5. Again, like with x, if I have a graph, I find where the line crosses the y-axis to find the y-intercept. If I have a table, I look for the y value that's paired with an x value of 0. So three different ways that I can find my x or y intercept, depending on what information I'm given. Now these practice problems should go into your notebook. When I look at this first one here, I see increasing temperature over time. I want to find and describe the x and y intercepts of each linear function. Well, if I think back to the slide that told me how to find intercepts, this one I'm given a graph. So what I need to do is I need to find where I cross each axis. So I cross the x-axis at 25. So that tells me that my x-intercept is 25. And I cross the y-axis at negative 4. So my y-intercept is negative 4. So those two ordered pairs that I care about, I have 25, 0, for my x-intercept, and I have 0, -4 for my y-intercept. Now I need to interpret what these mean. Well, this x-intercept tells me that when the temperature is 0, it has been 25 minutes. My y-intercept tells me that when I have 0 minutes, the temperature was -4. Next example here, I have Eva's distance from home. And this one I'm looking at the table, so I need to find my x and y intercept. Well, the first one I see x is 0, y is 4. Is this going to be my x-intercept or my y-intercept? Well, if I think about the information in my table, I have x is 0, so that's where I'm on that x-axis, which means that I'm crossing at y equals 4. So this one is my y-intercept. My other spot that I see is 8, 0. Well, that one's going to tell me my x-intercept. I'm crossing the x-axis where, oops, there we go. It's hard to write on the screen here. I have an x-intercept at 8. That tells me that at 0 minutes, Eva is 4 miles from home, and at 8 minutes, she's home. She's 0 miles away. Well, now let's look at this last one here. I have an equation, and I want to find my x and y intercept. So what I'm going to do is I'm going to figure out, I'm going to pop that graph there so it stays out of the way. I need to plug in my zeros. So if I plug in x equals 0, I'm going to find my y-intercept. 5y plus 5. Take away 5 from both sides, and I get a -5 equals 5y. So I get -1 equals y. So when x is 0, y is -1. Well, now I'm going to do the same thing for the other way. I'm going to plug in y equals 0. So I get x equals 5 times 0 plus 5. And I get x equals 5. So I know that when y is 0, x is 5. Well, I'm going to take it one step further, and I'm actually going to graph that information now. I'm going to use this information to create a graph. So I have the point 0, -1. Shows up on my graph right there. And I have the point 5, 0. My linear equation then is going to be a straight line that goes between those points and extends to infinity on both sides. So I can create graphs using my x and y intercept. Last year you spent a lot of time graphing in slope-intercept form, and we will come back to that again in a day or two. But this here, I can use my intercepts to graph. Now let's keep practicing with that idea. I have 2 more example problems here, and I'm going to find the intercepts and use them to create the graph. So for the first one here, I'll plug in x is 0 first. I get 0 minus y equals -3. So right now I'm working on when x is 0, I want to figure out what y is. I get -y equals -3. And this is one that threw many of you off on the math test. It was a similar question. That -y really tells me a -1 times y. So y, when I divide both sides by -1, I get y equals 3. So my first intercept is 0, 3. Well, now I'm going to work that out the other way. I have x minus 0 equals -3. And that's pretty straightforward. I find out that x equals -3. So I get -3 for x when y is 0. I'm going to take those 2 ordered pairs. I'm going to plot them on my coordinate grid here. I have 0, +3, and I have -3, 0. When I connect those 2 dots with a straight line that goes to infinity, straight-ish because Miss O'Leary is writing on a computer screen here, I can see that my graph should look something like this. Now with this next example here, it's in slope-intercept form, and I know how to graph that in slope-intercept form if I remember back to last year, but I want to use the skills I'm working on in this unit. So the first thing I'm going to do is I'm going to practice by plugging in 0 for x. I'm going to try to find my y-intercept, and so I find that y equals -6 times 0 plus 8. Well, that b value, my intercept, y is 8 when x is 0. And then I'm going to use my skills to find my x-axis intercept. And I'm going to plug in 0 for y equals -6 x plus 8. Well, I've got to take away 8 from both sides, and I get -8 equals -6x. Divide both sides by -6, and I get a -8 over a -6 equals x. I can simplify it. When I simplify, a negative over a negative is positive, and 8/6 is the same as 4/3. This is going to be difficult to graph on the page that I have here, but we're going to try our best here. We get 4/3. So my two spots that I'm going to graph is I have 0, 8. So 5, 6, 7, 8. We're going to say that it's going to be somewhere around here. And I have 0, 4/3. So 0, 4/3, which is a little bit more than 1. And when I plot those two and I connect with a straight line to infinity on both sides, I can see that it has a negative steep slope. If I'm looking at my equation in slope-intercept form, it should have a slope of -6. So I can graph in standard form by using those zeros, using my intercepts. Now our last one, this one here needs to go in your notebook. For D and E, you can put them in your notebook if you choose. I think they are useful, but they're difficult to graph. So you can choose to leave them out of your notebook as long as you understand. This last one here, though, is a little challenging, and this is actually straight out of your homework assignment. It's page 166, number 37. An artist completed an ice sculpture when the temperature was -10 degrees Celsius. The equation T equals 1.25 H minus 10 shows the temperature H hours after the sculpture's completion. If the artist completed the sculpture at 8 a.m., at what time will it begin to melt? Well, first here, I need to figure out what is this question asking. I want to know when it'll melt. So I know that water starts to melt when it's at 0. So when the temperature reaches 0 degrees, it'll start to melt. So I'm going to plug in 0 for temperature, that T. And I find 0 equals 1.25 times some number of hours. And it started at that -10 degrees. Well, the next thing I'm going to do now, I just have to solve for the number of hours. I add 10 to both sides. And I get 10 equals 1.25 hours. Divide both sides by 1.25, and I find out that I get 8 hours. But 8 hours isn't my final answer here, because I need to answer the question, if the artist completed the sculpture at 8 a.m., at what time will it begin to melt? 8 isn't the time that it begins to melt. I need to think about 8 hours, or 8 a.m. plus 8 hours, what time will that be? So using my wonderful counting on a clock skills, I find out that my final answer here is going to be 4 p.m. or 1600 hours if we were in Europe where they use a 24-hour clock. So this math is correct, but this is not the final answer because it doesn't answer the question that's being asked. Make sure that you have all parts of this in your notebook for the notes and that you get it correct on the homework assignment. So now, your homework assignment for this one here covers 2 different pages because we've squished 2 lessons in here. First, you have page 159, 3 through 21, multiples of 3, 49, 58, and 69. And then on page 166, I want you to complete 9, 23, 36, 37, 46, and then 51 through 57, all of them. Get this done in your notebook, and then when you are finished, turn in the assignment on Teams. Make sure you leave a blank page for your table of contents if you're completing this activity at home. Thanks, guys.